Welcome, everybody. My name is Felipe Castañeda, Creative Director here at MakerBot. We talked earlier today. And yeah, I'm joined today by Peter Boeckel, Industrial Design Manager at Peloton, and good friend, avid cyclist. He does these crazy rides across the state now. Pretty impressive. I'll let him talk about that. But yeah, today, radical innovation, unlocking the future of consumer products in a conversation with Peloton. So welcome, Peter. It's really good to have you here.
Hello. Thank you for having me. Glad to be here. I should take you on one of those long rides, Felipe.
I'm trying. I mean, I don't know.
It's a good stress coping
mechanism. And bike. Yeah, no, we collaborated in the past, previous experience in Steelcase. So we've been doing both industrial design for some time now. But let's talk about you, Peter. Like, tell us about yourself, what you've done so far. And now that you joined Peloton, kind of like your overall job description and what you do within Peloton.
Yeah, sure. Well, I'm originally from Germany, born, raised, and studied industrial design in Germany. And right after my graduation, I actually moved to Hong Kong, where I spent actually most part of my professional career learning. I joined Philips Design. That was my first job in Hong Kong, and company like Philips Design, you learn everything about process and scale, how a big design org works, how they work in process. But you also learn, obviously, being close to China and working in China, you're learning the entire manufacturing game, big factories, and that was back then a great and lucky opportunity to have to kind of get like thrown into the wild waters of the manufacturing game, as well as design. That suggests that I started my career in consumer electronics, Philips Design. I moved into office furniture. I believe that's where we met, Felipe. For a company called Steelcase, American company, still based out of Asia at that time. At Steelcase, I learned everything about I always call it the perfect process, but more like how do you search for the right questions before you start delivering answers. And next to corporate or working in big corporates, I got a bit of experience working in a startup. I moved to Singapore to work for a tech startup, which was based in music tech. I used to be like a hobby musician. I think I can say that. So designing music instruments was always a sort of a big thing for me. But more so, I got to design process and designing a team from the ground up, which obviously at that time was a very intriguing thought. I returned to Hong Kong and even returned to office furniture, but then in design leadership and led the Asia design team for Steelcase. And I moved to New York last December. In a year, I would think I would not move. So
quite a time to move to New York.
It was quite a time, yeah. Not that it was cold. We also have a pandemic going on. So I moved to New York City and joined Peloton, where I'm now since I think 6 months and a few blurry days. And I work as a senior industrial design manager here, and I'm leading the tread team and the bike team. And very, very fortunate to lead a group of very talented, creative people here. And yeah, so far it was a good ride, as we say at Peloton, definitely.
So let's start with that, like overall Peloton, and if you can describe the types of products that you typically work on with the team, like what are you already mentioned, like it's the bikes and the running machines, but let's think about or talk about, if you can double down on those and the timelines perhaps, and the overall process that it takes for you to, from an idea development and then getting into the market.
Sure. Now, obviously both products or items suggest that they have a certain size. So developing a certain size, those are complex hardware solutions. They're complex engineering, they're complex in design. It's also a very sort of young category as fitness moves into your home and you start living with these machines or devices. How did they start look and feel as you start living with them in a much closer proximity? As that eventually used to be the case with normal fitness equipment, which was in your gym. You would go there, or it's maybe still in the gym of your building if you have one. How do we develop this? I mean, given the size, it obviously takes longer than when you work in, like, let's say, consumer electronic. I used to work in headphones. A headphone from first sketch to first ship, you do in 6 months, maybe shorter, depending on how ambitious it is. Here, that is obviously longer. How do we develop at Peloton? I think we're not too different from most other hardware developing companies, right? We have our product development process that has phase gates and milestones, and it has responsibilities. And obviously, in a fairly classic industrial design manner, we collaborate obviously with mechanical engineering, electrical engineering a lot. But then also, as you work in a company like Peloton, where you have hardware as well as content and software sort of playing together, you also work with the software people. And I think that was for me one of the very very attractive things joining Peloton, obviously. Now, I mentioned already software and hardware. So there's also obviously a huge member community. Members are number one at Peloton, number one priority. And of course, working in development, that also provides to be a very cool research ground, right? So we can do research with our members. We have an instant feedback loop. That is almost like you would have it when you work in a tech company, and imagine you push like a software feature. You get fairly quick feedback if that works or not. And that so far at hardware obviously used to be a bit more of a struggle, right? You have long development times. At some point you have to cut into physical steel. Getting feedback on hardware or testing such, if you don't have a fixed member community, always a bit tricky. Here, that's very cool that we can do that. And yeah, with that in place, it's very exciting. We can get a lot of data that we have flying into our development process. And well, that allows us to make eventually certain decisions quicker, or figuring early out where to drill a little bit deeper.
And speaking about like specifically the hardware development, what are the types of tools and assets that you use at Peloton, such as either meals or printers, that, those elements that allow you to do quick testing and, faster turnaround times when approaching new ideas?
I have a feeling you're getting to 3D printers here.
Okay. Of course I am.
Yeah.
No, I mean, we've worked with you guys a couple of times in the past, but I think it's really interesting, to think about how a facility is set up, especially in a city like New York, right?
Yeah.
Like, what are the challenges of that, and what are the implications of?
Yeah, that's true. Actually, yeah, very, very good question, especially when you put it into the context of a city like New York. Our office is in Manhattan, where I'm right now. So we're getting ready to eventually move into a brand new office. And Peloton as such has made a huge commitment into hardware and into prototyping facilities. So we're having various shops, and we have a main shop. And yes, of course, we're utilizing everything that the almost normal hardware development process has. However, the tools we always had, and in the future we will have, they always evolve, right? So we all remember the time when 3D printing used to be something like very special, and now it's like part of your almost standard toolkit. So yes, we do have a whole fleet of 3D printers that runs almost 24/7 or 24/5 eventually. I don't know, but around the clock, our lab technicians say. So that obviously helps to speed up and to get to certain decision-making points quicker. What happens before that print is not too different than what it used to be before, right? We build dimension models by hand, we sketch, we do a lot of CAD. I think that is, in order to 3D print something, you do have to do some form of CAD, at least at this point where we are. But then we're also using, and we're all living through that still, some parts of the world more, some others less, our pandemic. So that obviously was a huge challenge to prototyping, but also how do we review prototyping, right? So we have obviously VR tools that we're using, and reviewing products in VR, or sketches or
right,
three-dimensional items. So I think
so like in the past, now that you mentioned like that tension of working remotely versus as a designer, or specifically an industrial designer, you sort of need the physical object to a little bit interact with it. So how has that been for Peloton? Are you guys balancing the remoteness? Are you completely back into the office? And then back when everybody was kind of working remotely, or trying to work remotely most of the time, how did you guys approach, access to your machines and the processes that you used to develop a new product?
Yeah, good question. I can only speak to what I've witnessed as I joined and onboarded virtually in a company, which in itself is already like a weird but fascinating experience, and it works fairly well, actually. I have to say that. So the team worked from home and remotely, as New York was in this lockdown. I moved from Hong Kong, where I actually never really experienced a lockdown. So when I heard through what sort of situations people went through here, I'm like, okay, kudos. That's actually quite tough, especially to your point when you're developing something. Now, if you probably can develop tech products fairly well remote, but the moment it comes to something becoming physical, and then the other challenge, looking together at the same object, I think this is the next challenge, and I'm sure I don't know if we ever will overcome this except by actually working together. So the team worked from home, access to model making or 3D printing was given on a special basis. I think product development teams or parts of these teams, it's not even the entire team, had access to the relevant facilities to sort of work things out. I think where 3D printing here helps is obviously if the physical world around you gets constrained, and let's say your model worker can't work, right? Then obviously your 3D printer still can work to some extent until you need, I don't know, new material and shop is closed. But I think, there suddenly 3D printing becomes a tool to not just, prototype faster and to eventually get to decision points quicker. No, it just simply helps to sustain a certain forward momentum. If it's the same pace, I don't know. If it's the same cadence, only the length of code will tell. But it certainly helps to, keep things running to some extent. So I think in that sense, it helped greatly. As we now have desktop-sized 3D printers, it's also not really an issue or a big thing anymore to ship a printer to someone, which is something that is similar when you had two development offices on two parts of the country, one coast and the other, and they would print both the same part and look at it still on Zoom. I think there's still something to be figured out, right? But in that sense, I think it worked actually quite well.
Then, in your experience, because I think it's always refreshing to hear it out, what's the relevance of having the physical prototype with you? You were talking about like that it's really important, but why? And what's the type of information that you get, from having the mock-up, the model in your hands versus having it in CAD and evaluating, say, a render version or a CAD version of the part?
Right. Yeah, I think you're touching like a point that's sort of close to the heart, and that's how we as designers that obviously define design and trying to create a physical experience, we're sort of working a lot in the digital realm. Now that has all its great benefits, right? But on the other side, those things are tools and they should always remain tools. So I think it's always that moment once you have a physical object and you put it in the middle of a table, it dominates, and it shows you we're hardwired, we're analog human beings or beings. And I always encourage get it into some sort of physical situation as quick as possible. Now, having obviously a 3D printer or having a very fast model maker, depends, or both, obviously helps. So getting the item finally gives you this sense of tactility. But then, there's also that moment, as I said earlier, looking together at a prototype, walking around it, gauging proportions, and you learn very quickly, on screen, that looked different. Yeah. And you're sort of almost glad that you did this because you almost had made a decision that was based on something that you saw on screen, which is only helpful to some extent. And I think...
and I can imagine like those decisions, that because it's also happening with our own development process at MakerBot. Sometimes those decisions can be rather expensive, right? So once you commit to, say, an injection molded part or a casted part, you're talking about a few tens of thousands of dollars just for the mold. So having a little bit more peace of mind and information becomes crucial to avoid that costly mistake.
Yeah, that's correct. Yeah, ultimately, when I say trying to get to two decision points faster, right? It's also about creating, for example, how do you float this or that idea throughout a group of people, like throughout an org or a team. And I think having a physical object always helps. Obviously, making this case. Yeah, totally.
And regarding like prototypes, and you mentioned that Peloton has basically, you made it sound like it, like you have every single tool available under the sun at your disposal. So specifically, subtractive versus additive manufacturing, thinking about milling and machining prototypes versus 3D printing them. How have you balanced those two? Do they complete each other? Do you rely on one or the other earlier in the process or later in the process?
Yeah. I think I think there's a longer and a shorter answer. I'm trying to get the longer one. We have, to your earlier comment, yes, we have a few tools that are quite nice. No, but at the same time, we're still building the majority of our facilities. So we do rely also on, of course, outside vendors, etc., like most developing product development companies do that. I think the major sort of line to draw is, and that's probably where 3D printing or prototyping is, right? Why it's still rapid prototyping rather rapid manufacturing at scale is you do the whole prototyping part when it comes to like the actual concept phase or thinking about the problem, right? And the great thing about speeding this up is you have more time to think. That's how I believe where actually the main benefit is when we're talking about doing things more rapidly. I don't believe it should speed up eventually your time to market. Ideally, you have, as a designer or engineer, you have more time to think, because the problems we're all going to solve are only going to be more complex and complicated. So now where you start, well, we start relying on, like, let's say a mill or so, where we actually mill something out, is when we're eventually in an engineering phase and we're much closer to how would we manufacture that later. Because there you deal with the eventually real world issues that you have in manufacturing, where it's not 3D printing, it is about mold directions, right? So, and I think this is where once 3D printing is sort of, and I think in the last, that eventually better 5 to 7 years, we have edged on that much closer into the manufacturing type with these new technologies. I think then this ratio might eventually change. I don't think we're there yet. It depends on, if you work in shoes, you're a bit closer to it. But I think this is an interesting line to watch, how we move this, right? And maybe in 10 years, my answer would be, we don't mill at all anymore, because most of the parts that we sell are actually 3D printed. I don't know, but it could be that.
So, and how possible do you see that happening? Like, especially now that you have so many different composites. And I don't know, like, for example, speaking about like the types of things that you could print, I guess they rely or are heavily connected to the types of polymers or base plastics or composites that you're using in the printers, right? So all in all, when using 3D printers, what types of materials do you usually rely on?
So in our at Peloton, in our design prototyping concept phase, it's the classics. It's more plastics, plastic-based material. It's also to confirm proportions, shape, etc. Now our items are at some point very big, so most 3D printers just simply aren't going to cut it. So we're actually going and order like a big, or in the future making this ourselves, like a big mock-up that's made out of foam. But it is in that sense, it is the sort of rather classic, materials like plastics. It's what's more interesting is what surface quality are we using?
Okay.
Right. So it could be very rough, it could be very fast in the beginning. As you process through your phase, eventually you print that in a more refined version, which in-house obviously is possible if you have a smaller sized part. Again, for a life size, let's say bike or treadmill.
I mean, because that's the thing, right? Even when using a full-on manufacturing process, the bike is going to be made out of or made up of multiple parts anyways, right? There's no like single sort of machine that can do everything in a single go. And here's your bike finished from top to bottom. You're going to be combining methods.
That would be the dream, but yet we could design each of these parts differently. And I think this is where most designers get excited about 3D printing when we're talking about manufacturing, right? And what can we do when undercuts aren't really an issue anymore? So when you can start really trying to think about new archetypes, or how do you fundamentally start questioning current archetypes that are really, if we're analyzing the world around us and how it's made, it's often also why archetypes are the way they are, because they're just made in a certain way, right?
Yeah.
And I think that's where, if you talk to designers about 3D printing, everyone's like, get the glow in the eyes when it's about, I imagine you can manufacture later.
And so, for example, when talking about concepts, like, let's say, do you guys ever plan 5-10 years into the future and say, like, well, when we stop using injection molding and rely, as you were saying, like 100% in 3D printing, we could. How often do you do those types of exercise where you sort of try to push the envelope beyond what's currently possible with your, install base or manufacturing processes, and more so into like the blue sky, thinking of, okay, everything's possible. What will we want the future of the bicycle to be like?
Yeah, I guess the question aims more for like, what type of innovation culture are you going to set up, right? So you mentioned the term blue sky. I personally am not a big fan of the term blue sky. I think it means too much and nothing by now. So I like to rather talk in possible futures or time horizon, like now, near, and far. I think and it's not just Peloton specific, but especially when you do hardware, you need to do a certain outlook, right? As tech eventually works in more incremental steps and has also the luxury of eventually doing so. And then there's a different in incremental innovation. Are you making micro steps, or are you making the right steps so that competition is always one step behind? I think that's the difficult part to sort of set up. And ideally, next to your day-to-day current life program business that you run, you ideally also have work streams running all the time that think, inform, question, trying to poke into the dark of, could this be a future, or could this be a future, right? And in those, you would then imagine multiple things, or you would put those explorations under a certain umbrella. So to your example, that could be one, right? Where we would say, hey, let's imagine, and again, is it a Peloton or any other company? Let's imagine if this thing is like made from one part, from one printer, what could we do if we had to actually go there? Now, is that time frame in which we would imagine that, is that real, or is it made up, or is it based on our somewhat knowledge in that field? How accurate that is, I don't know. If I could answer you when we could print a bike entirely, that would be great. I can't.
No, for sure. And one of the things that you're making me think of is, especially with these digitalized products that have, whether it's some sort of interface, some sort of digital layer to them, like with Peloton, as you were saying, it's not just a bike, it's the whole experience, the sort of content that comes behind it. How do you mix and match the sort of the talk that happens between the hardware itself and the digital layer, the added content layer, from your perspective?
Yeah. So interestingly, it goes back to the earlier point I said, if you have a huge user base, then you can use those as a research ground, right? So, and then there's always software, and we have a research team that facilitates all these research programs. The talk between software and hardware, it depends really on the part, right? So currently our content is running on a tablet that is fairly separated actually, and from the rest. So there is obviously talk. It really depends on what component and how a hardware component is eventually triggering an action or an item that is actually visible on the screen, or vice versa, although that is less of the case. So then we're getting to talks with the UX UI team, or eventually give them also trying to give them certain ideas. Obviously I have ideas as well. I think more important is to say that we're coming from the hardware experience part, and we're trying not to separate, okay, there's stuff that goes on the screen, and we're trying not to say this is not part of the hardware experience. It's part, the user doesn't care, right? For the user, it's one great, awesome experience. There is no deciphering eventually, oh, this is screen, this is that. No, it's a Peloton experience. So yeah, where necessary, we absolutely connect on these things and prototype this together.
That's good. And so far, what's the most, I guess you cannot talk about current development and kind of like new products coming to market, but overall, what are some of the parts that you can talk about on the development process specific to any parts that you've sort of interacted so far with Peloton that have been particularly challenging or representative of your time there, and yeah, give us a good glimpse of the development, going back to that process behind the scenes a little bit.
Yeah, I think yeah, nice try. No, I cannot talk about current programs. I think challenges are I'm bringing it a little bit back more to the current time we're in, and that like working together in the same physical space is difficult. And I think when you develop a product, and probably counts for companies who do all kinds of, let's say you develop a product that has a high degree of ergonomics involved, right? So how do you test this? How do you get eventually people in a room, make them comfortable and test things? So yeah, that's, I think, the biggest challenge, or one of the big challenges, because that's something you cannot really compensate for in like a virtual environment, nor can you ship half-cooked prototypes around and into people's homes. So that's probably a tricky one that we had to deal with. We made it work somehow, right? I'm not sure if that answers your question entirely.
I think so. I mean, it also reminds me of some, especially now that you mentioned the ergonomics of a bike seat. I mean, it's as, say, close contact as you can have of an object with a user, right? It's like very custom, the way that we all see it on the bikes, and we've seen like a lot of examples in different companies trying to test out custom 3D printed saddles or 3D printed shoes to sort of better accommodate for the users.
Yep.
Have you guys explored any such ideas in saying, well, how do we create the bike that's tailored made for the user and not just like an average of ergonomics?
Well, I guess that is still and will be for a while to come, I believe, the dream of every designer or engineer that works something that's hyper ergonomic, right? How can you come to the number, like the 0 point, or that one model that's perfect for you? And I guess it goes back to what's the future of 3D printing look like? I mean, that's certainly a future that is, I believe, waiting to be unlocked. As usual, I guess price plays a role in here. We do know there are bicycle saddles that are eventually made or 3D printed. We don't use them at this point. I think cost is another point. So far, when we look at shoe brands printing sneakers, right, or running shoes, those are also shoes that come with a certain price tag. I think it gets, like every manufacturing, every new technology, it becomes interesting when it enters the sort of regions in terms of pricing where you just simply can start using them for mass. I guess that works with every new technology like that. I would love to custom make 3D printed saddles for
saddle, I mean, Physique has them, so I don't know
exactly.
why
Yeah, that's a good question.
And with this, I'm going to also start asking you guys, everybody in the chat section, if you have any questions for us. Alejandro is collecting them all, and we'll be going through them at the end. But I think that we've also seen a lot of people coming into these, conversations that are students or higher ed, college students. So, what would your advice be on somebody who's interested or already like studying industrial design, on things to keep in mind when developing a new product? How do you sort of use all of these tools that are now available to you because of what you were saying, right? Like now 3D printers are super accessible, even CNCs, you see them scaling down and being a little bit more easier to deploy, or you may have access to them in your school. What are some of your key things to keep in mind when developing a new product and thinking about, like, the designers of tomorrow, as they sort of start incorporating and jumping into the workforce? Yeah,
well, I think I remember when I joined my first job, and I realized pretty quickly everything I had done got me to this point, but it will not get me further. So you will start learning again, and I think that's something to keep in mind. What I'm sort of observing cautiously and sometimes a bit worried is eventually, and we're coming back to our favorite topic, social media. If we're looking at platforms like Behance, great platforms. You know, they sort of give you a great tool to showcase your work, but it also suggests a work or a world in which product development is sort of effortless and very shiny. It always looks great. And it doesn't really show, unless you show it on your profile, it doesn't really show how much work it actually is, how much failure goes in there. So I guess the problem I'm seeing here, that there's a sort of perception shaping up that, you know, this is all like fairly quickly done. You can be famous in no time. Fame, if you want to be famous, don't be a designer. Just I don't know, play music and be good at it. But I think the whole nitty and gritty nature of actually product development and getting a product to market is something I find when I talk or, you know, work with interns in the past. It's like, oh, whoa, this is what it all takes to get a product out. It's so small. Yeah, but this is exactly what it takes. And we already talked a little bit about manufacturing. So I think as a young designer, I would cautiously advise, don't think what you see on Behance is overnight success. There is no overnight success in this or any industry that develops hardware products. It's hard work.
I think you're also touching on a very interesting concept of this idea of failure and being able to make mistakes. So just like, and I see, you know, somebody asking like, okay, what would be your sort of number of failures that it'll take for you to come up with the final part or the final answer to something that you're developing and working on? Like on average, how easy it is for you to get to the final answer? Meaning the reps that you will have to make.
How many we make, or how? Oh, it's a lot. I mean, it depends also how do you find that, right? If you start at the very beginning of your process, like, is it 1 out of 5 sketches you like? Okay, then you have 4 failures. If you want to call them failures, I call them just thinking. As you go, you make 3D prints and you decide for one. And are the other 2 failures, or are they just part of that word failure? I think for designers should not be as threatening. Failing is part of the game here. And same it is when you sort of, you know, go to an engineering prototype and it breaks. Is that a failure, or is it just part of a learning curve? So I'm cautious of where do I apply that word failure, because I think it's such a heavyweight word. I think break things and see what breaks and what doesn't. But maybe a better way to say is, if something doesn't work in the beginning, then you just need to try it again. Again, going back to that overnight success, not everything seems so easy. Just because you make a kick-ass render and post it on Behance doesn't mean you have developed the product. There is a lot more to it. And I think that is, people who have gone through a Kickstarter campaign know that by now. They're like, oh, this is really hard work.
I mean, I think that it's actually like Luis is asking a similar question on just the number of iterations and pages that you go through until you reach the final and desired product, right? I guess also connected to it, you know, what's the access that the team has to iterating? Like, let's say if one of the team members has a good idea, can they just quickly go into the printer, throw it in, test it out overnight, and then come back the next day and say, hey, this is my proposal of sorts? Yeah,
pretty much. I mean, we have a shop at Peloton. We have a shop or shop. If you have an idea, you print it, right? I usually say to my team, we make decisions on models. We don't make them on renders. So now as a designer, how much time does it get me? How much time do I need to get to that model, right? What do I need to prepare? So yes, everyone, you can, there's no permission needed to ask to use a 3D printer here. Now, if you want to use a 5x milling machine, that's a different conversation, obviously, right?
Yeah, for sure.
But for 3D printing, I mean, that's one of the beauties, right? You have an idea and you refine it to a certain extent, and then you can fairly effortless, you can get it out into the real world and bring it to a meeting. I remember times where you would like need to book model shop time, and then you would, you know, so that's all to some extent cut out. And I think that's part of the beauty that of the development world we're living
in. And one of the common questions that we have here are, you know, usually people wonder, what's the type of specific setup that you have? Like, for example, speaking about 3D printing, what are the types of machines that you currently run at the Peloton shop?
We have a bunch of MakerBots, obviously. We have a bunch of comes with the territory. We have a bunch of Ultimakers. We have the, what's the other one called? It's an SLA machine. Small. They're all desktop versions. Yeah. They're all desktop versions. and they're accessible. Almost every designer can operate them. Now we have the luxury, we have a technician who sort of operates them for us or maintains them. But then, if you get to a certain threshold of 3D printers, I just had a look in the shop. I think it's about 10 or 12. So there's quite some work involved at some point.
I see also a question on like the scale itself. So, and I just to wrap the types of printers that you use, because it's always interesting to hear and refreshing, because it's hard to tell the story of, hey, FDM, SLA, more industrial machines, they all have their applications, and it depends, right? A Formlabs will not do what a MakerBot printer will do, and a MakerBot printer will not. I mean, it all depends on what you're trying to achieve.
Right. It depends where you are, right? So if you're not using, I mean, as you, let's say, paint a picture, use different brushes for different parts of that artwork. And it's same with the printing or any tool of the development process. Now the question is, if we prefer a particular scale, I think if you can, always go 1-on-1. You develop for humans operate 1-to-1 scale. So if you, now that's not always possible, but you try to piece it together. But
and so, for instance, when you're doing 1-to-1, especially considering the fact that these bikes can be rather big, what's your take on just slicing components of it versus doing the full build at once?
Yeah, I mean, ultimately, it comes down to why are you prototyping this, right? Because you want to get to a decision, you want to get to an evaluation that gets you to a point. Okay, I learned this, I'm going to move on. So are you going to do this by 3D printing because the scale allows, or you have the machine? Are you going to do this by building a foam core mock-up, which eventually gets you to a similar decision? If you need a certain refineness and it's too big and you can't print it, can you chop it in parts and print it? Or are you going to, I don't know, get someone to mill it out of foam, right? Ultimately, don't be taken back what you can or cannot do with that machine. Try to get there somehow else. What you want to get to is, you need to get to a decision point. That's what a mock-up or a prototype is good for. And there are various ways of how to get there. But to answer the question directly, yeah, if you can, always 1-on-1, 1-to-1 scale.
Yeah, so, and just they are elaborating on the question. So fitting form and function to the human scale, essentially.
Yeah, totally. I mean,
So no, that's good.
That's you mentioned earlier CAD reviews, right? So yeah, you do a CAD spin, okay. You can evaluate eventually engineering problems. You can look at an overall shape in a design context. But to really evaluate it, you want to look at the whole thing in front of you in context of physical space. I used to work on chairs, and a chair on CAD always looks bigger than what it actually is, because you never look at it from, that height where your eyes are when you stand up. So this chair,
no, it's hard to abstract it. And I mean, you've even seen it with some design software evolving into VR and using the goggles. It's still, even if you have that representation there's something physically missing.
Exactly.
We're just very primitive, I guess.
Yeah, I was just about to say that. Yeah. So we are, even though, yes, you can get a somewhat projection illusion of a 1-to-1. It eventually gets you a little bit closer to something. But if you want to sign off on something, you have to get.
That's great.
Yeah.
So I think we're about to start to wrap things up, and for now, I think Peter, thank you so much. I don't know if you have any last comments that you want to make to the audience here. Thoughts on the future of 3D printing, the upcoming projects and products that will be released next quarter for Peloton.
That's also another nice try. I realized that, Felipe. No, I think, the future of 3D printing is everyone. I'm no different. I'm excited about rapid manufacturing and what we can do. If we imagine we could do things on a fairly large scale, printed, and I think as you start thinking of what you could revolutionize with 3D printing at the mass scale on a mass manufacturing term, it's quite fascinating, right? It goes from questioning archetypes, developing new products in a shape or in a technological way that you couldn't do it before, all the way to reshaping economies, because you could mount 3D manufacturing machines on a truck and drive them somewhere. They would just do it there. So I think that's, for me, where I get excited when I talk about rapid mass manufacturing. I don't know how to call it. rapid manufacturing.
Rapid mass manufacturing.
It's quite a mouthful.
All right. Well, thank you so much, Peter, again, for joining us today. I'm sure that we'll be working somewhere in the future. And then everybody, thank you guys so much for joining our session. If you have any more questions, you can go ahead and send them out to hello@makerbot.com. We'll be sure to forward them to Peter or give you an answer. And then, of course, there's a final session with Pfizer coming up in a few minutes. So please stay tuned for that one. But again, thanks, Peter, for joining us. And yeah, we'll talk again soon.
Thank you. Thank you, everyone.